You're swimming in clear tropical water. Visibility is perfect. You feel something brush against your leg, soft and silky. Then the pain hits, not gradually, all at once. Like someone is branding your skin with hot iron while running electrical current through your body simultaneously. You scream and surface gasping, looking for what attacked you. There's nothing. The water is completely empty. You can see 10 meters in every direction, and there is absolutely nothing there. But your muscles are locking up. You try to swim toward shore and your arms won't respond. Something invisible just sentenced you to death. Chironex fleckeri has killed at least 79 people in Australia since 1883. In the Philippines, estimates put the number at 20 to 40 deaths per year. That's more fatalities than sharks have caused in the last 40 years combined. And most people have never heard of it. The box jellyfish is not the largest predator in the ocean, not the most aggressive, not the one that generates headlines when it appears near beaches. But it is statistically the most lethal animal in the sea. Most ocean predators give you time to react, time to fight back, time to make it to shore. This one doesn't. What makes it so dangerous is not just the venom, it's the speed. The animal itself looks like something that shouldn't exist. The body is shaped like a transparent cube, up to 20 centimeters on each side, with up to 60 tentacles trailing below it. Each tentacle can reach 3 meters in length when fully extended. The entire organism is more than 95% water, which makes it almost completely invisible in its natural habitat. You can be swimming directly toward one and not see it until contact. And unlike every other jellyfish on Earth, this one hunts. Most jellyfish drift passively, waiting for prey to blunder into their tentacles. Chironex fleckeri swims actively at speeds of up to 2 meters per second, roughly the pace of an Olympic swimmer at moderate effort. It can turn 180 degrees in just a few pulses. It has 24 eyes, not light-sensitive patches. Actual eyes. Some of them have corneas and retinas that function almost exactly like yours. Scientists still don't know what a jellyfish does with that much visual information or how it processes images without a centralized brain. But the eyes work. The animal uses them to navigate through underwater obstacles, avoid predators, and track prey. It hunts small fish with precision, adjusting its trajectory mid-swim to intercept them. Which means, when you enter the water where Chironex fleckeri lives, you are not trying to avoid it. It is deciding whether to avoid you. Most of the time it does. Sometimes it doesn't, and sometimes you brush against a tentacle while it's hunting something else entirely. Each tentacle contains approximately 500,000 cnidocytes. Those are stinging cells. When they make contact with skin, they fire in 700 nanoseconds. That's faster than you can blink, faster than your nerve endings can register the sensation of touch, much less pain. The firing mechanism generates acceleration forces comparable to those used in ballistics. A microscopic harpoon punches through your skin instantly, inverting from inside the cell like a pressurized needle. And here's where it gets worse. The firing is not a decision the animal makes. It's a mechanical response. The cells are triggered by specific chemicals present in human skin, not by pressure or intention. A single point of contact means hundreds of thousands of harpoons deploying simultaneously across the length of the tentacle, and each one is pumping venom. The venom contains more than 170 different proteins, and they attack your body on 3 fronts at the same time. First, your skin cells start dying on contact. The classic box jellyfish sting leaves raised welts in a crosshatch pattern, marking exactly where the tentacles made contact. Second, your muscles stop responding. The venom blocks the signals your brain is sending to your arms and legs. You can't swim toward shore anymore. You can't pull yourself out of the water. And third is what kills you. The venom punches holes in your heart cells. They rupture. Potassium leaks into your bloodstream in concentrations your body was never designed to handle, a condition called hyperkalemia. Your heart enters severe arrhythmia. The pain is described by survivors as being branded and electrocuted simultaneously. Victims beg to die. Most deadly animals give you time. A venomous snake bite? You have hours to reach a hospital. A shark attack? You can make it to shore if the wound isn't catastrophic. This? 2 minutes. Cardiac arrest can occur within 2 minutes of a severe sting. Every documented death in Australia happened within 5 minutes of contact. That's the amount of time it takes to call for help, explain what happened, and wait for someone to arrive. It is not enough time. Australia has recorded 79 confirmed deaths since 1883. The most recent was in 2022. A 14-year-old. The Philippines reports 20 to 40 official deaths per year. But specialists believe the real number could be as high as 500 annually. Most don't make it into any record, they're just gone. The majority of fatal victims are children. Smaller body mass means the venom reaches lethal concentration faster. But the most common cause of death is not the venom finishing its work. It's drowning. The sting causes immediate paralysis and panic. You can't swim. You can't stay afloat. You go under before the cardiac arrest kills you. The marks on your skin, if your body is recovered, remain visible for months. In some survivors, they never fully disappear. The scars are permanent, raised and discolored, a grid of lines showing exactly where the tentacles wrapped. And even if you survive the initial sting, there's more. Survivors report persistent heart arrhythmias years after the incident. The venom doesn't just damage your heart, it changes it. You'd think we'd have figured this out by now. We haven't. Anti-venom has existed since the 1970s. It was developed in Australia, and it works by neutralizing some of the venom proteins circulating in your bloodstream. The problem is that it only works if administered within 5 to 10 minutes of the sting, which is exactly the window you don't have. Most box jellyfish stings occur on remote beaches with no nearby medical infrastructure. By the time you reach help, the venom has already done its work. The anti-venom can stop additional damage, but it cannot reverse what has already happened to your heart. And here's the other problem. Scientific studies on the anti-venom's effectiveness are conflicting. Some show clear benefit, others show marginal improvement at best. And here's what we still don't understand. There are more than 250 proteins in Chironex fleckeri venom. Scientists have isolated and described many of them, but they don't know how all of them function or why the combination is so uniquely lethal. There are at least 51 species of box jellyfish worldwide. The antivenom developed for Chironex fleckeri does not work reliably on stings from other species. In 2019, researchers at the University of Sydney tested an experimental drug that blocks the venom's effects in mice for 15 minutes. It has not been tested in humans. We can describe the venom. We can isolate its components in a lab. We just don't know why it kills so fast or why some people survive stings that should be fatal, while others die from contact that seemed minor. The most dangerous animal in the ocean is not the biggest. It's not the strongest. It's not the most aggressive or the one that hunts humans intentionally. It's almost invisible, has no brain, and kills without intention or awareness. The lethality is not in the monster. It's in the chemistry, in the speed, and in the complete absence of warning. You can't see it coming, you can't fight it off, you can't outswim it, and by the time you realize what happened, your body is already shutting down. That is what makes Chironex fleckeri more dangerous than anything else in the sea. Not malice, efficiency. Protective nets on Australian beaches have reduced deaths significantly. Thailand implemented safety measures after tourist fatalities at popular resorts. But in the Philippines, which specialists call ground zero for box jellyfish fatalities, the animal continues killing dozens of people every year, most of them children. No medical records, no protective nets, no warning signs. The water looks safe. It isn't. The invisible cube is there, drifting or hunting. 24 eyes scanning the water, 500,000 stinging cells primed on every tentacle, waiting for the chemical signature of skin. But there is a marine predator even smaller than this one, and that one doesn't even need to touch you to kill you. If this was worth your time, consider liking, and I'll see you in the next one.